Hi there, welcome to my final year project presentation. Project title, Effect of CRUMB Rubber and Waste Engine Oil on Mechanical Properties and Durability of Recycled Aggregate. Before we go into project detail, I would like to express my sincere gratitude to Ali Rahman, Syed Usman Ali, Zain Ulabedin, Muhammad Khizr Khalid, and Project Supervisor, Dr. Danish Farouk, for their guidance, massive support and expertise. The topics to be discussed in this presentation: Introduction, Problem Statement, Objectives, Methodology, Results, Conclusion, Social Economic Benefits. Introduction. Waste tire rubber and engine oil offer sustainable solutions for asphalt pavements, enhancing properties while addressing environmental concerns. However, recycled aggregate and admixtures contribute to pollution, requiring attention to environmental issues. Problem statement. Dumping recycled aggregate harms the environment, while traditional aggregate usage depletes resources and escalates costs. Although higher recycled aggregate content in asphalt may improve rutting resistance, it can worsen thermal cracking. Objectives. Assess long-term performance and durability, focusing on cracking, rutting, and moisture damage. Evaluate economic feasibility compared to traditional asphalt mixtures. Contribute to natural resource conservation and overall sustainability. Targeted Sustainability Development Goals. There are 17 goals which are set by the United Nations to attain a sustainable future. Our research will target SDGs 8, 9, 11 and 13. Methodology. Replace coarse aggregate with recycled aggregate, 30% and 50%. Incorporate CRUMB rubber, 7% and 8%, and waste engine oil, 7% and 13%, into the mix. Conduct various tests to evaluate stability, density, rutting, and other properties. Materials. Materials we used in the project: aggregate, waste engine oil, CRUMB rubber, bitumen, and methylene chloride to clean and recycle asphalt pavement. Mix proportions and quantities of materials. We use CRUMB rubber for 7% and 8% of the aggregate. The percentage of fresh aggregate is 50% and 70% and recycled aggregate is 30% and 50%. Results. CRUMB rubber enhances bitumen properties but reduces ductility. Optimal bitumen content identified, 4.76% for performance grade 60/70ths. A sample with 7% CRUMB rubber, 7% waste engine oil, and 50% recycled aggregate had a maximum rutting of 11.89, while one with 8% CRUMB rubber, 7% waste engine oil, and 30% recycled aggregate had a minimum rutting of 4.87. These graphs of the Marshall test are drawn to find optimum bitumen content. These graphs show the maximum and minimum rutting values, and a comparison of these rutting values. Conclusion. Bitumen properties like softening point, flash point, and fire point rise with CRUMB rubber addition. The optimum bitumen dosage is 4.76% based on performance grade 60/70ths. In-wheel tracker tests, 7% CRUMB rubber, 7% WEO, and 50% recycled aggregate resulted in max rutting of 11.89, while 8% CRUMB rubber, 7% WEO, and 30% recycled aggregate showed min rutting of 4.87. Socioeconomic benefits. Utilizing recycled aggregate reduces dependency on traditional coarse aggregate, preserving resources. Recycling minimizes landfill waste, pollution, and ecosystem degradation, promoting public health and community well-being. Incorporating recycled materials reduces construction costs, enhancing economic viability.